Recalling quadratic equations. In previous chapters, we explained that quadratics are equations where the highest power of the dependent variable is 2. A quadratic equation with one variable, as the name suggests, is a type of equation that contains a single variable raised to a maximum power of 2. The variables in the first power are also present in the same equation in many cases. We usually express the variable by the letter x, but other letters can also be used. A quadratic equation with two variables is an equation where the independent variable, usually x, is at the second power at maximum, while the dependent variable, usually y, is always written to the first power. Second-order equations with two variables are also known as quadratic functions. They are called quadratic because quadratum is the Latin word for square, and since the independent variable is raised in the square, we call these equations quadratic. For the general form of a quadratic equation with two variables, we have the following shown on screen. Where a and b are coefficients, numbers preceding variables, while c is a constant, free number, not followed by a variable. If the dependent variable is taken as 0, we obtain the corresponding quadratic equation with one variable. We have the following shown on screen. Equations of this type are solved by checking the sign of the discriminant delta first. The discriminant is an expression of the type. We have the following shown on screen. Thus, if the discriminant is positive, delta greater than 0, the quadratic equation has two distinct solutions. We call them roots x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus square root of delta over 2a. If the discriminant is 0, the quadratic equation has a single solution, root, since the part inside the square root becomes 0. Sometimes we say the equation has two equal roots. We have the following shown on screen. This is because x1 equals minus b minus the square root of 0 over 2a, and x2 equals minus b plus square root of 0 over 2a, and we know that the square root of 0 is equal to 0, so that part disappears from the formula. When the discriminant is negative, the quadratic equation has no solution. This is because the square root of negative numbers does not exist in the set of real numbers. Last, the shape of quadratic graphs is a parabola. This is because, in geometry, the equation of a parabola has the basic form y equals x squared. All the other elements added in the formula, such as any coefficient a, preceding the variable x, any bx term or any constant c, simply make the parabola shift, stretch, compress or flip vertically in respect to the basic form y equals x squared. The figure shows an example of the graph of a quadratic equation, y equals 2x squared plus 5x minus 4. It is nothing more than a quadratic equation with two variables shown on a coordinate system. We have the following shown on screen. That is all for lesson 15.1.1. To continue this tutorial, please watch 15.1.2, Plotting Quadratic Graphs. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.